If you had a square and decided the best way to express the total length of the outside of the square was to start at the center, measure that distance to the edge, call that the squareus, and then notice after measuring millions of squares that the total outside of the square, which of course we would call the square circumference, was, let's count them, 1, 2, 3, 4, 5, 6, 7, 8 times the squareus, which we would call x, every single time, you might start to think that 8 was some magical number relating to squares and their square circumferences, or rather that 4 times the square diameter was. Well, that's what pi is, but for circles. Except it ends up not being a straightforward integer like 8 or 4. It ends up being a transcendental number. Please watch Stand Up Maths for more on pi. The ancient Egyptians and Indian mathematicians, as well as Chinese, Greek and Roman mathematicians did lots of calculations to find out that if you take the circumference and divide it by the diameter, you get a little bit over 3 every time, no matter how big or small that circle is. That's why I call pi the magic circle ratio. It shows up in nature everywhere. That's why I like pi.